Greetings, this is Artie from Artifact Electronics, and look what I just picked up. This became available in a local sale, and so the seller told me that his wife bought this for him several years ago, and he played it a lot, and then it died. It was a stormy day, there was thunder and lightning, and it just died on him, and he just wanted it out of there because he was moving. So generally it's not in too bad a shape. Control panel is going to need replacing. It's complete, everything is there. Coin door looks suspiciously new, and we'll get to that in a minute. But the side art's nice on both sides, and the back is, well, it's kind of dusty, but it's the back of an asteroid. So let's open her up. It was sold to me as being completely dead, and it is. Doesn't do anything right now. So let's have a look inside. The owner didn't have any keys. He said he's never opened up the machine. But board's pretty nice looking. No apparent hacks on it. The regulator looks good. Power block looks good. But on visual inspection, the first thing I found, that there was a blown fuse. It's the second fuse from the top. And it's a 20 amp fuse. So I replaced that, and I did some quick measurements to see if anything looked shorted, and nothing looked shorted, but the game still wouldn't turn on. So finally, my buddy was looking at it, and he called me over, and can you see that? Yeah, this is where the AC power comes in. 3 wires. You have your white, green, and black. That's directly connected to the power plug, and it goes into the main transformer over here. And the black wire over here was out. It had basically come loose from the crimp connection, so the machine wasn't getting any power at all because it wasn't hooked up to AC. So I took that out, and tried to recrimp it, and then basically took the wire and soldered it directly to the connector. I didn't have a replacement for that, and so then it was time to finally turn it on, knowing that it would get power, and see if any fuses blew, if there was any magic smoke, or if everything was back to normal. One thing to always check on these games is they basically got electrical safety interlocks, so you don't just open the back door and electrocute yourself. And the way these things work, here's the one on the back door, is when the back door is on, it pushes it in and closes the circuit. You remove the door and it interrupts the AC, and nothing happens. It also has a third position, a service position. You can pull it out, and that basically overrides the safety. And a lot of times these switches will have turned or aren't in the right position for the door when the door is closed to fully depress them, and the machine won't get any power and it won't turn on. And this one kind of looked like this when I got it. So that was, I was hoping that there was a high probability the safety interlocks. A second one is behind the coin door, by the way, exact same principle. And I thought, oh, this thing is bent, so maybe it doesn't work. But initially, even when I put both of the interlocks into the override position, nothing happened. So let me make sure that they're both on and actually go ahead and power up this unit. And of course I may have misspoken. This is not an Asteroids, but an Asteroids Deluxe, the follow-up to Asteroids, which Atari came out as a follow-up, and the main thing they seem to have corrected in this game, as I recall, was people figured out how to play Asteroids for a very long time on a quarter. And this game, the way I remember it, is a lot more difficult than a plain Asteroids, and consequently didn't do nearly as well as the original. But anyway, I found a curious thing that I wanted to show you here. Here we're looking at the inside of the coin door, which has coin counters. Two of them, one for the left and one for the right coin make. They're kind of like odometers because they count the number of coins that have been dropped in. Now, if we look at the bottom one, we can see that it reads 560. We look at the top one, it says 32, which generally means that there were slightly less than 600 coins dropped in this machine, or more correctly, in this coin door. Now, this was a home game. The switches are set to free play, so it didn't count the games that people played in their home. But still, 600 coins passed through the coin doors. It's about $150. So I'm kind of debating whether this could be an almost home use only machine. Now, some of the exterior belies that because it does have some scrapes and bumps on it. And of course, one thing that I'll never know is this the original coin door? I mean, the coin door does look suspiciously clean. Nobody kicked it. There is a slight dent on the side right here where somebody may have tried to pry it open, but I guess that's a mystery that'll never be solved because Atari did not serialize their cabinets. So you don't even have a valid serial number to trace this device. But you never know. Maybe it was moved around a lot in its life, and the control panel, which is all cracked up, that's usually, even if you don't touch these, the plastics they used didn't weather well over time. But enough of all of this. Let's go ahead and try to power it on. Okay, here we are at the back. Remember that fuse I showed you earlier that I had replaced? It was kind of a dumb thing. It had that ceramic coating you couldn't see inside. So I just put a regular glass fuse in there so we can see it blow up when I turn it on, or not, but at least we'll know what's happening there. So we're all plugged in. The front safety interlock is in the service position. And here we go. Nothing on the screen. It keeps repeating that, playing the little welcome song. Actually, what I think that is it's telling me there's something wrong with the board. It's the self-diagnostics communicating with me. Nothing on the screen. But you'll notice that the start game lights are blinking. So the CPU is good. I mean, it's doing something. I can start a game probably. But the monitor is blank. So just to test that, still nothing on the screen, but oops. Well, it looks like something's working, except we can't see it. Now I messed around a little bit more with it, Stuck my head in there. Don't know if you can see it, but come on. Well, the neck's actually lit up. I can hear vector chatter, but it seems that it doesn't have any high voltage. And what I did was these machines are famous for the connectors on the deflection board cracking the solder joints. So I went and played around with those connectors, and I briefly got an image. Of course, the camera wasn't running, but it was extremely bright. The intensity was turned all the way up. The Z didn't seem to work because everything was connected to each other. There never was any blanking. But that only lasted for a few minutes, and then the screen went blank again. One other major giveaway, though, is that these monitors, the spot killer wasn't lit. What does that mean, you ask? Well, a vector monitor, if it doesn't get a signal, the beam would be hitting the dead center of the tube all the time. And if you let that go on for a long time, first it'll burn through the phosphor, and eventually it'll actually burn through the glass. It'll puncture the glass, and you will be having lots of electrons spilling out, and depending on their configurations, fry you really good. So what they did on these monitors is their protection circuitry that detects if there's no valid signals coming in on the X or Y, and if that happens, it turns on the spot killer circuit, which turns off what shows up on the screen and lights an LED on the deflection board. That LED is not lit, and me hearing monitor chatter is it's doing something. And obviously I saw an image, which even though I'm not showing you, you're going to have to trust me, but it had problems with the high voltage because it was super bright. I could not adjust it, and so we definitely have to have a look at the monitor, of course. But the other thing we're going to look at is that little tune it played at the beginning. It was basically 2 high notes and 1 low note. And I looked in the manual, and that basically tells me that the RAM at location, what was it, M3, is defective. Well, I guess so. First we're going to pull the PCB, find out what sort of RAM that is, and see if we can replace that, and at least get rid of those annoying introductory sounds it plays. And then after that, I guess it's on to the monitor. Alright, let's start with some fault isolation. Remember this guy? That was about a year ago. I found him at a thrift store. Anyway, it's a plain Asteroids, but I checked the pinouts, and they're compatible enough for me to be able to test the Asteroids Deluxe board here for display, but I'm not going to be able to play a game because the controls are wired differently on this, and so is the sound, by the way. But at least let's say if this puts on a proper image, and that'll go a long way towards fault isolation. So I'm going to turn this on with the interlock. Can't see anything. Oh, there you go. Well, it comes up and goes into demo mode properly. So even though it did complain about that RAM, which by the way I looked it up, it's one of the vector RAMs, it's a static RAM, seems to be working okay. Well, that is probably something we'll chase down when we get the monitor fixed. I don't just want to go in and tear into this thing now. I've checked the voltage up in the garage cabinet, and it was 4.9 volts. A bit low, but not low enough to cause... It shouldn't be low enough to cause a RAM error. And this voltage is closer to 5 volts, but it still gave us the warning. So let's go up and figure out how to get the monitor out of that cabinet. So while removing the monitor, there's one other thing I wanted to point out. Notice the tube is sticking straight up. And what you're seeing in the back there is there's a mirror mounted right here. So it's coming from down here, getting reflected off a mirror that sits at the correct angle and throws the image towards you. See in the corner those screws sticking out? Somebody tried to remove the mirror and just left the screws hanging in the air. That's very nice of you, thank you. Anyway, what mystified me was, so how come this ran correctly on my cocktail? I mean, it wasn't upside down or this or that. Everything looked correct on it. And after looking at the schematics, I discovered that the PCB has two jumper fingers, or let's say a jumper finger and a ground right next to it, which is left open in the upright, so it knows to properly invert the image. But on the cocktail, those two pins are jumpered, and that way the machine knows not to invert when it's not supposed to invert. But anyway, I'm almost there, and a couple more screws and I should be able to slide out the whole monitor shelf and gain access. Well, I was able to remove the monitor without breaking anything, including the mirror. It did look like the monitor had been removed, or at least attempts had been made to remove it, so there was a couple of screws missing, and I had to be really, really careful whenever loosening a screw to make sure nothing fell down. But anyway, we're looking at the deflection board here, which is the first one we're going to examine, because the main connector from the game that supplies everything to this board comes from here. Goes into here. And it supplies all the voltages, and also the voltage that then goes into the high voltage cage and feeds the anode to the tube. Now remember, the tube lit up. I heard vector chatter, and even though I was unable to show it, I actually did see a picture on the screen, even though it was really, really bright. And then I played with some of these connectors over here, and the picture disappeared. So let's have a quick look at the deflection board. So I poked around the deflection board. All the solder joints looked good. I checked a few components, checked the bridge. Everything seemed okay. And then I checked the obvious, and that's the fuses. There's 3 over here, and 1 over here. And this one was open. And you couldn't really see it. It's not going to focus on it. But, looking at it, it looked fine. Nothing seemed to be broken, no burn marks in it or whatever. But do not base your judgment of a fuse's functionality plainly on visuals. Measure it. The thing was open with a 5 amp fuse, and it was basically in the supply that feeds the high voltage. It was, let's see, F101 over here. So there was still some voltage coming through, but just one leg of it was blown, so that would obviously give you some very strange results. Now, while I was at it, I pulled out the high voltage cage and opened it up. Did a visual check on the HV diode over here, which looks good, flyback. No burn marks, no leaky caps. All of this needs to be recapped. But right now, I'm just trying to get the machine up and running. So we found something that could definitely have caused our problem. Fuse F101 over here. So let's give it a quick test. Well, it still didn't work. Same thing, I heard chatter. The spot killer light wasn't on, but there was no display on the screen. So I took out the high voltage cage. I measured the input voltage, which was exactly 40 volts DC as required, but all of the voltages it generated were low. Anywhere from 5 to 20% lower than specified. And I could not adjust the anode voltage. It was kind of stuck at around 9.5 kilovolts, and you couldn't adjust it. So obviously something was wrong in there. So I started measuring all sorts of components, and I mean the HV section for a vector monitor is somewhat similar to the horizontal section in a raster monitor, in that you feed it a voltage, then you have an oscillator running, creating a sinusoidal voltage that is fed through the transformer and thus generates the high voltages. While the transformer, it's still falsely called a flyback. In this case, obviously a vector monitor doesn't have a flyback, so we'll just call it the transformer. But I just poked in there and started measuring components, caps, everything. And the caps all measured kind of funny, so I pulled them out of circuit, and the electrolytic ones, of course, the ones over here, this one, and this one, tested good out of circuit. But this one, I pulled out. Probably my camera won't show it properly. It won't focus on it, but as I desoldered it, it fell off the board once I had one leg desoldered. So one leg was broken off, and it obviously had leaked and eaten off its own leg. So I replaced that capacitor, and when I checked in the schematics, the capacitor in question is this guy. And obviously, if this is the oscillator section here, if this guy is open or shorted or whatever it was, the oscillator can't be adjusted anymore, and your voltages will be off. So let's see if we found the problem. Okay, I got it hooked up to the cocktail asteroids. The pinouts match on the monitor connector. And, well, let's see. I got the high voltage probe in there, so we can adjust, if necessary, the 12 kilovolts. And all I did was plug it in right there. So here goes nothing. Come on. Oh. Well, looks like our fix was good. It's working. Great. I can finally go to bed. Well, let's have a look and see what the high voltage looks like. And it's right on, 12 kilovolts. And that kind of makes sense because we didn't change, we only changed one of the capacitors in the oscillator. Well, it should have been different a little bit maybe, but I guess we just lucked out. So here's our screen coming out of a regular Asteroids cocktail. And that's enough for me tonight. Tomorrow we'll go and put it back into the Deluxe and see what that looks like. Well, on second thought, I'm going to end this one here. because I got a bunch of stuff to do tomorrow, and I kind of want to wrap this part 1 up to be able to post it soon, and then we'll do a part 2 with the Asteroids Deluxe. Thanks for watching. A thumbs up would be appreciated. Subscribe, and you'll be notified when part 2 shows up. And make sure to leave me a comment. We'll see you in the next installment.